Okay, there are two ways to think about this problem. Okay, we want to find f inverse of negative 11. Let's think of f inverse as g of x. So if we want to find g prime of x, in other words, f inverse prime of x, then it would have to be 1 over, in this case, we have to have f prime of g of x. Okay, now another way to view this is we're basically looking at reciprocals. If we knew the slope of f of x at a point x, then we would know that whatever that was, the slope, that would be the same as 1 over g prime of f of x, where g was the inverse. Likewise, g prime, you can switch these like this, f prime of g of x. But the point is, we don't know, we can find f prime, and then if we find if we knew the x value associated with negative 11 y value, then we could compute it. We could just take the reciprocal. So that's really our problem. We want to know what value of x causes a negative 11, because that value of x is going to be the inverse value of in other words, we're starting with this, negative 11, and this is f of x. We don't know the x, but we do know that on g, which is the inverse, let's say g is the inverse, we do know that this would be true. G inverse of negative 11 would be x. So once we find that x, we can use that in our formula here. So that's why we're going to do it this way. Now this becomes 27 times 11 equals x to the fifth plus 2x cubed, and we can write that as 0 equals x to the fifth plus 2x cubed. I think I said this is a polynomial problem, finding the 0. You can see right away that it's got to be a negative, and that a negative 1 won't work, too small. But some factors of 27 might work, and I might try with negative 3. So let's check negative 3. Negative 3 to the fifth plus 2 times negative 3 to the third plus 27 times 11. Does that equal 0? And it turns out that it does. Yes, it does equal 0. So we do have a negative 3 as a 0 here. And it's going to be the only one, because if this is my function f, then quick look at that. Because you might be saying, well, does this thing even have an inverse? Well, we're assuming it does, because it wouldn't ask us to do it if we couldn't. So I won't even waste any time on that. But this turned out to be an increasing function. If you find the derivative, just see that. So it's 1 to 1, and it has an inverse. So that means since it has an inverse, then this is the only number, negative 3, that when generated, when used in f, would give a negative 11. That means that this point here is a negative 3. So that tells us that g of negative 11 equals negative 3. Okay, that's what it tells us. So all we have to do now is let's find the derivative. Because right over here then, g prime of that negative 11 equals 1 over f prime of g of negative which we know is 1 over f prime of -3. So now all we need is f prime to be in business. So f prime is 7, 5x to the 4th plus 6x squared. And when evaluated at -3, we end up with 17. I didn't show that. But that is the answer. It's 17. So that means finally we can finally put this number in here. 1 over 17 is our answer. And again, you might be saying, why didn't we just find G inverse, calculate its derivative? Well, we could have, had we been able to find G inverse from this guy here. But it's anyone's guess that can even be done. So we've avoided that by using a little bit of luck. If this had been any other number besides -11, I don't know if we would have been able to solve this resulting equation. So we did kind of take advantage of the situation. But it did illustrate some of the ideas also concerning inverses, domain, range, and so forth, and our new idea of the reciprocal nature of the derivatives of an inverse and its corresponding function.